Imagine a sunset on a planet that orbits a black hole. Or one that stops, reverses, and happens twice in the same day. Or a Martian sunset that turns blue. This is not sci-fi. These are real physics. You see, there are 2 trillion galaxies out there in the universe, and within them, there are billions upon billions, trillions upon trillions of stars. Our Milky Way galaxy alone has at least 100 billion planets. Think about that, 100 billion. Some orbit 2 stars. Some orbit dead neutron stars. Some even orbit black holes. The universe is a strange place, and the view is about to get spectacular. So buckle up. We're traveling from Mercury to the edge of the known universe to witness the most beautiful and deadly alien sunsets you've ever seen. And stick around to see a sunset on a planet orbiting a black hole. In our solar system, Mercury has the weirdest sunsets. The sky here is always pitch black. That's because Mercury doesn't have any atmosphere to scatter sunlight like Earth does. But even though Mercury doesn't have epic twilight, it has something better. Double sunset. Yeah, if you were standing on Mercury, you'd see the sun slow down in the sky and then stop, reverse for a bit, and then fully set over the horizon. That's not a simulation mistake. That's a normal day on this planet. Mercury has a very oval-shaped orbit, and it speeds through it faster than any other planet in the solar system. But when it gets to its closest point to the sun, it speeds up drastically, like a slingshot. On average, Mercury rotates on its axis exactly 3 times for every 2 loops it makes around the sun. But when it's at its closest to the sun for a few days, Mercury is moving around the sun faster than it's spinning on its own axis. And that creates the epic double sunset you can only see once in 176 Earth days. On Venus, you never actually see the sun as a distinct disk in the sky. That's because this hellish planet has an incredibly thick atmosphere, and the atmospheric pressure here is 93 times higher than on Earth. Unlike on Mercury, all you'd see on the surface of Venus is thick, yellow sulfuric acid clouds. Lots of them. And as the sunset approaches, from the surface of the planet, the sky never turns to starry night. Instead, the yellow glow just deepens into a dark red and then fades into a pitch black night, where no stars are visible. But you'd have to wait a long time for this sunset. One day on Venus is 243 Earth days long. That's even longer than a Venusian year, because Venus only takes 225 Earth days to orbit the sun. But don't mix that up with the solar day on Venus, which is another way of saying a full day-night cycle. That solar day here on Venus lasts 116 Earth days, and the actual sunset isn't a 15-minute spectacle. It lasts for days. No matter what planet you're standing on, watching a sunset has a way of slowing everything down. But back here on Earth, the moment we look away, well, reality tends to rush back in. And one of the biggest modern stresses most people don't even realize they're dealing with is how exposed their personal information really is online. Yeah, identity theft and online fraud aren't rare edge cases anymore. According to the Identity Theft Resource Center, the number of data breaches jumped 211% from 2023 to 2024, largely driven by massive large-scale leaks. That means names, addresses, phone numbers, emails, even sensitive records are constantly being collected, sold, and resurfacing on data broker sites without people even knowing it. Well, that's where Incogni comes in. Incogni is a personal data removal service that automatically tracks down and removes your information from hundreds of data broker and people search websites. Instead of spending countless hours sending takedown requests yourself, Incogni handles the entire process for you and keeps repeating it because your data can reappear over time. And now with Incogni's custom removals feature, well, you can go even farther. If you find a website that's exposing your personal information and it's not covered by their automated system, well, you can simply send Incogni the link. Their privacy experts review it and take care of the removal for you, even on sites outside their standard broker list. If you want to try it out for yourself, Incogni is giving our viewers an exclusive deal right now. Just go to incogni.com/what and use the code WHAT to get 60% off an annual plan. So while we can't all watch sunsets from every planet, well, we can remove a little unnecessary stress from life on this one. Incogni helps you take back control of your personal data so you can spend less time worrying about who's watching you online and more time enjoying moments like this. Mars has this cold, red desert vibe during the day, but as the sun sets, the sky actually turns blue. Yeah, the reason behind this is that the atmosphere on Mars is very thin, less than 1% of Earth's, and it's filled with teeny tiny dust particles, or iron oxide and magnetite. These particles are micro-tiny. They're about 30 times smaller than a single strand of your hair. Yeah, if you scale a human hair to the width of a soda can, a particle of Martian dust would then be the size of a single grain of rice. During the day, the iron-rich dust in the Martian thin air scatters sunlight. That's what gives Mars its signature red planet look. But the sunset is where all the physics get flipped. All because of what scientists call me-scattering. Those dust particles are almost as small as the wavelength of blue light, so they don't just absorb blue light, they act like tiny directional mirrors. Instead of bouncing the light everywhere, they scatter the blue light forward. So when the sun is low in the horizon and you're looking right at it, that blue light is beaming directly into your eyes, cutting through the haze. Science. Now, Jupiter is a bit of a bummer because you can't land on its surface. Now, gas giants like Jupiter and Saturn, just the same as the ice giants, Neptune and Uranus, don't have any surface at all. They're just super heavy clouds with cores at their center. So, while you can't see what the sunset looks like from Jupiter's non-existent surface, you can still look at it from Jupiter's cloud tops. From here, the sky would look dark blue, darker than the deepest ocean on Earth. And the sun here is just a tiny, incredibly bright button in the sky, only a fifth of the size we see it from Earth. That's because Jupiter is far. Yeah, it's 5 times farther from the sun than Earth. Okay, Jupiter doesn't have retrograde sunsets or blue sunsets, but it has speed. Yeah, this giant rotates incredibly fast. It makes one full rotation on its axis in just 9 hours and 55 minutes. So, in one Earth day, this giant has the sun setting and rising 2.5 times. What's a half sunset? Anyway, basically it's a sunset on fast forward. Now, while we're hanging around Jupiter, let's take a break from all the planets and look at some of the solar system's largest moons. Io is a volcanic hellscape, the most volcanic moon in the solar system. It spews volcanoes like Earth did in its early days, and it even has an atmosphere. But that atmosphere is super thin and mostly made up of volcanic gases like sulfur dioxide. Because the air is so thin, the sky here is mostly black, even during the day. And sunset here is no regular sunset either. It's a sunset/solar eclipse. Yeah, every 42.5 hours, the sun hides behind Jupiter. And it's not a fast kind of eclipse either. If you were watching sunset on Io, you'd see the sun disappear behind the gas giant for 2 solid hours. And this is Europa. It's quite the opposite from the volcanic world that is Io. This moon is icy. Europa has a very thin oxygen exosphere. It's like an atmosphere, but way too thin. So the sky here is black even during the day. But when the sun finally sets, Europa gets a glow up. Literally, this moon is being constantly bombarded by intense radiation from Jupiter. And all that radiation slams into the ice on the surface and makes the ice molecules release energy as light. So as soon as that tiny sun vanishes below the horizon, the ground beneath your feet would start to shimmer. The landscape would glow with a faint light, like you wouldn't even need a flashlight to see where you're walking. Okay, next up is the solar system's heavyweight champion moon, Ganymede. Yeah, this moon is so huge, it's bigger than Mercury. If it orbited the sun instead of Jupiter, we'd call it a planet. And it's the only moon in the solar system with its own magnetic field. That means a sunset on Ganymede comes with a light show. As twilight hits, you'd see auroras. Yeah, just like Earth's northern lights. Well, almost. The Hubble telescope has detected Ganymede's auroras mainly in ultraviolet, so you wouldn't see them in our simulation. And you wouldn't really see them if you were standing on the surface, unless you used specialized equipment. And finally, Callisto. This rock orbits Jupiter, only much farther away than its other large moons. From here, Jupiter would look about the same as a grapefruit held at arm's length. Now, you'll see the same kind of sunsets as you would on Io, with Jupiter blocking the sky, but Callisto doesn't get an eclipse every day. Yeah, it has a tilted orbit and often misses Jupiter's shadow. You'll have to wait 3 years to see one of these sunset eclipses. Okay, enough with Jupiter. Let's move on to the moons of Saturn. This is Titan, Saturn's largest moon. And it's a special moon. No, it doesn't have volcanoes like Io or glowing ice like Europa. It's got a thick atmosphere, and its atmosphere is even denser than Earth's. But even more than that, Titan is covered with lakes. Only these lakes aren't made of water. These are lakes of liquid methane and ethane. In this thick atmosphere, the sunset would take the landscape from hazy orange to deep brown. And with Saturn so big in the sky, well, what a view! Now, speaking of Saturn, this planet, just like Jupiter, is a gas giant, so no surface to land on. And just like on Jupiter, you'd have to watch the sunset from the cloud tops. But the sunset isn't the main event here. The rings are. During the day, the icy rings reflect sunlight, And as the sun sets, you'd watch the shadow of the planet itself creep across that arch, extinguishing the ring light section by section. It's not just the sun going down, it's the lights going out on the biggest structure in the solar system. Man, I wish Earth had something like that. Okay, past Jupiter and Saturn and all their moons, there's Uranus. This planet is weird. It rolls around the sun on its side instead of orbiting it straight like other planets do. Because of this tilt, if you were at the pole of Uranus, you'd have to wait 42 Earth years for the sun to set. It would just spiral around the sky. But when the equinox finally comes and the sun does set, it's beautiful. The atmosphere of Uranus is full of methane, and methane is a gas that absorbs red light. So as the sun dips, the sky doesn't turn orange or pink. It fades from a bright cyan to a deep turquoise color. Makes me feel kind of cold. Next up is Neptune. This is the furthest planet from the sun. I know this because Pluto is not a planet, not officially. Neptune orbits the sun 30 times farther than Earth does, so things here are pretty dim. Out here, the sun is 900 times dimmer than it is on Earth. A sunset on Neptune is a shift from blue to total blackness, so not as spectacular as you might have pictured. Moving on. To Pluto. I know, I said it's not classified as a planet, but it still holds a special place in the solar system, and in my heart, and in the comments section where you're constantly telling me it's still a planet, but it's not. A dwarf planet / X full-on planet, it even has its own moon, Charon. Now, Pluto is even further from the sun than Neptune, so it's even darker here on this rock. If you stood on the surface of Pluto at sunset, you wouldn't see a black sky, you'd see a blue one. A really, really, really dark blue sky. And you could see Charon from here, forever locked in the sky. That's because Pluto and its moon are tidally locked, so here you go, a sunset on Pluto. Now, as sunsets seem to look darker and more boring and more darker and more boring as we get further out in the solar system, well, I think it's time to travel outside our planetary neighborhood. Okay, this is Kepler, but not your favorite 22b. This is Kepler 444c. This one is half the size of Earth. This rocky planet is 119 light years from Earth, where it orbits a dim and small K-type star. But it orbits really close, way closer than even Mercury orbits our sun. So that small K-type star looks massive in the sky. And this rock is Kepler 452b. Which scientists often call Earth 2.0, mostly because it orbits a similar sun in its habitable zone. The main difference is that its star is about 1.5 billion years older, so it's 20% brighter than our sun. You see, stars like our sun tend to get brighter when they get older, just before they turn into red giants. So a sunset here would be bright, but very similar to Earth's. And in case you forgot what an Earth sunset looks like, well, here's a beautiful sunset simulation for your reference. Another Earth-like planet is TRAPPIST-1e. Look, it even has auroras and a beautiful atmosphere. But you're not here to watch regular sunsets. You want to see the epic stuff. I get it. And I give you PSR B1257+12c, or simply Poltergeist. It's one of the first planets ever discovered, but it doesn't orbit any kind of star. It orbits a pulsar. This pulsar is called PSR B1257+12, or LIC. It's only about 20 kilometers in diameter. From Poltergeist, it looks tiny. Yeah, that blindingly blue-white point of light? That's the pulsar. Pulsars are extreme. They're neutron stars spinning so fast that they sweep beams of radio waves and other radiation across space like cosmic lighthouses. Some blink just a few times per second, and the fastest pulse hundreds of times per second. It's incredible. This specific pulsar spins 161 times per second, so the sunset here has a bit of a strobe effect. And it goes back and forth like that as the planet turns away from the pulsar and back at it. Things are spinning fast here. Now, this celestial rock doesn't have any nice name. It's called WD1145+017b. Scientists don't bother giving it a more memorable name because it's being vaporized by the white dwarf it orbits. The white dwarf is about the size of Earth, but it's as massive as 60% of our sun. It burns with a hot blue-white light, and with every sunset, it rips the planet or a planetesimal that's left of a planet apart. But this is nothing compared to the scariest of sunsets. The kind of sunset that happens when a planet orbits a black hole. This is an extremely beefy, supermassive black hole, Holmberg 15A star. It's a black hole in the middle of the galaxy Holmberg 15A, which is 750 million light years away. This black hole has a mass of 22 billion suns. Yeah, I'll let that sink in for a second. 22 billion suns. Orbiting something like that would be deadly, but with an unimaginable view. And this is a planet orbiting a black hole in the galaxy IC1101, which also happens to be the largest known galaxy in the universe. This black hole is even more massive than Holmberg 15A star. It has about 40 billion solar masses, and it's way, way farther away, at 1.1 billion light years between this monstrosity and planet Earth. Oh, and this black hole is even more massive. This is Ton 618, and it's got 66 billion solar masses. It's quite a bit farther away at 10.8 billion light years from Earth. Now, scientists think that planets orbiting black holes exist, theoretically, and they could even orbit black holes in stable orbits. But we don't have the technology to observe those kinds of planets just yet. Detecting a planet orbiting a black hole or a planet is tough. And that's because they're small and dim, and the areas they're in are so chaotic. We can't use our regular planet hunting methods here. We've got to come up with something new. Well, I don't know, like maybe we send Chase to spend 1 nanosecond in a black hole. See if there's any planets around.
I don't
But
think they're supposed to stretch
that's
like
a story for another What If.